Good day, young statistician. Welcome to the line of best fit contest. So if you missed class today, or perhaps you were here but just needed a bit of a refresher, let's go over how the line of best fit contest works. It takes up part of assignment 8, part A. So let's begin. You're given a scatter plot. Here is only 7 points in the scatter plot. We'll start first with the easy stuff, the association. So remember, association has three descriptors. One is the direction. So is it going in a negative or positive direction? So this is positive, this is negative. So it certainly looks like it's a negative direction. So we'll go with a negative. We also want to talk about how strong the association is. If the points are kind of all over the place, that's kind of a weak association. The more in formation the points are, the stronger they are. So I'm going to look at this, and that looks like it's a pretty strong association to me. So I'm going to go negative strong. And then the third part is the shape, which we either are looking for either linear or curved. And to me, it looks like a line would be probably the best fit for this. So negative, strong, and linear will be my description. Again, you can use these words in any order you want. You could say linear, negative, and strong, strong, linear, and negative. You'll probably get comfortable with a certain order, but that's up to you. Now, the next part is a bit of a guess. You're now going to guess at the equation of the trend line, and the trend line is what we call the line of best fit. So what you're going to have to do is you have to first of all start by drawing it. You're going to try, and I would suggest you get a straight edge of some kind and try to draw the line that you think best fits this data. So here I have a straight edge. I'm not sure who this fine fellow is, but he certainly needs a shave. Anyway, let me kind of take this and see if I can kind of fashion a line that goes through the points pretty well. So I'm going to draw a line right about, maybe right about here. So once I've decided on a line, I'll kind of draw that line of best fit right down through the middle. Okay, so there's my line of best fit. That's the line that I think fits the data the best. So once you've drawn it, now you've got to figure out the equation. So you got to think about slope and intercept. So what I've drawn here, let's see, this is 5, this is 5.5. So it looks like my intercept looks like it's about, I guess I'm going to call that about a I'm going to call it a 5.7. And then I've got to think about the slope. And so remember, slope is about rise and run. So I'm going to kind of just sort of count boxes here. And so if I would go maybe down 2 over 1, 2, 3, 4, 5, 6 and a half. So that's a bit awkward. Let's see if I can get something a little cleaner than that. Well, maybe down 3 over 3, 6, 9, now 10. Okay, so down 3 and over 10. So my guess is going to be y equals negative 3/10 x, and then my intercept, I believe I said it was about a 5.7. So let me just double check that real quick. So it went down about 3 across 10. I think I may want to change my guess a little bit here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I'm going to keep it at negative 3 over 10. So, and I'll just go ahead and turn everything into decimals. Y equals, I'll get a little more lead out here. Y equals negative 0.3x plus 5.7. So that's my guess at the equation of the trend line or the line of best fit. And I would also like you to go ahead and put down a guess for the correlation. Last week we did a little bit of correlation guessing. So let's see, I'm looking at this and it's certainly not a 1.0. And I think I said strong correlation. So I want to pick something between like, 0.7, 0.8, 0.9, something thereabouts. So I'm going to guess that correlation, and we often use the letter R. I'm going to go with r equals a negative, because it's going downward, negative, and I'm going to go with a 0.8, and that'll be my guess for the correlation. We're going to test these guesses out a little later on. Okay, so that's the first part of this assignment, is to describe the association, come up with what you think is a line of best fit, and then come up with the equation for the line you've drawn, and then estimate the correlation. Now, once you've done that, we're now going to test and evaluate your line and see how well it fits the data. And so here's how we're going to do that. In the bottom half of the paper, okay, I've set up a little chart, and your work's going to be different than mine because you're probably going to pick a different equation than I am. So I'm going to write for myself here my equation, y equals negative 0.3x plus 5.7, just to remind myself what the equation is. And so the first thing I have to do is you do what's called predicted y. And what we're going to do is we're going to use the equation to make predictions about the y variable. And so here's how we do it. We're going to plug in 1, and we're going to see what the y value is. So if I were to put 1 in here, this would be, well, negative 0.3 plus a 5.7. That would be a 5.4 when I added it up. Okay? I'll now try the number 2. Okay? And again, at some point you might find you need a calculator. Feel free to use that. So I'm going to do, let's see, so negative 0.3 times 2, and then plus 5.7. And so I get about a 5.1. So put a 5.1 right in here. And then you'll go on doing the rest of your guesses. I'll show you one more, and then the next I'll just go ahead and do quietly. And if you want to move the video ahead, you can. So let's see. So negative 0.3 times 4 minus, whoops, that should have been plus 5.7. And I get about a 4.5. So I'm going to go ahead and figure out the rest of these. And again, if you want to just move the video ahead, feel free. I'll try not to take too long. Okay, so I've finished with my predicted y's, and so I took each of these x's, plugged it into the equation that I think is the line of best fit, and here's what we got. These are called the predicted y's. The next step is to find what's called residual. Now, residual, another word we often use for residual is the word error. So you might want to write the word error on your sheet. Error and residual are two terms that mean basically the same thing. And so here's how you figure it out. Now, the actual y turned out to be a 6. That was the point on the graph here, was 6. But your equation is predicting something different. It's predicting something right here. It's predicting a 5.4. So there's some error here. In other words, your prediction is a little off from what really happened. And so in order to find the error, we simply take what the number should have been minus our prediction. So 6 minus 5.4 is a 0.6. And then you go to the second case. Well, the reality was 4, but we predicted a 5.1. So 4 minus 5.1, negative 1.1. And so on. You continue to find the error in each case. 4 minus 4.5 would be negative 0.5. And I'll go ahead and do the rest of these. Again, if you want to move the video ahead, feel free. double check my work here. 0.6, negative 1.1, negative 0.5, 0.5, negative 1.2, negative 0.9, and 0.07. So I believe I've got my error numbers figured out pretty well right there. So, okay, so with the error numbers figured out, the residuals, you'll notice that some of these are positive and some of these are negative. And that should make sense. If your line is kind of passing right down the middle, you would expect there to be some positives and some negatives. Now, also, but there's more to it than that. Here's a residual of 0.6, okay, and it's a positive number. That's telling you that the point is actually sitting 0.6 above the prediction line. So wherever you have positive residuals, okay, so 0.6, let's see if there's some other positive residuals. The fourth case is a 0.5. So here's a residual or error of 0.5. And it looks like I should have one more positive residual here. And I do, it's that 0.7. So the points that are above the line will exhibit what's called positive residual. And the points sitting below the line, well, those are going to exhibit what we call negative residual. Okay, and so there's probably 4 negative numbers in the table, and there are 4 negative numbers. Okay, so one little test is to just simply add up all your residuals and see what you get. So that's something else once you have your line I'd like you to do. I'm going to go ahead and do it for mine. 0.6 minus 1.1 minus 0.5 plus 0.5 minus 1.2 minus 0.9 plus 0.7. So hopefully I typed that in properly and I'll hit equals. And so I get a negative 1.9. Negative. And so this is what's sometimes called the sum of errors or sum of residuals. And so it looks like I've got a little more negative residual than I do positive because I ended up with sort of a net negative. Some of you may end up with positive, excess positive residuals. Those of you who are really good at this, you'll get something really close to 0. And that's kind of the goal here, is you're hoping your residuals will get as close to 0 as possible because you want the positives and negatives to kind of balance out, much like an average does for a set of numbers, is the deviations end up being 0. Here we would like the residuals to be 0. So mine is, mine could probably be better. I'm at this stage going, oh, I probably don't have the best fitting line here. Mine's pretty good, but hopefully you'll be able to do better on your guess. The other thing you're going to calculate is you're going to find what's called the square residual, or what we often call the square error. And so much like we did with standard deviation, where you found deviation, then you went ahead and squared it, okay? We're going to do the same thing with residuals. So 0.6 squared is 0.36. 1.1 squared, I believe, is 1.21. I should probably at some point have my calculator ready just to double check my calculations here. Let's see, 1.1 squared. 1.21. Of course, I don't need to worry about the negative. I know that squares always turn out positive. So 0.5 squared would be 0.25. So that takes care of these right here, 2.5. And this one's also going to be 2.5. 1.2 squared will be, I think, should be about a 1.44. 0.9 squared should be 0.81. And 0.7 squared will be 0.49. So you figure out these square residuals, and then you're going to go ahead and add all these up and get the sum of squared residuals. So I'll definitely use my calculator for this. So 0.36 plus 1.21 plus 0.25 plus 0.25 plus 1.44 plus 0.81 plus 0.49. So I get a total of 4.81. 4.81. 1. Okay? And this is what's called the sum of the squared residuals, or sum of the squared errors. In fact, you'll see this used a lot, SSE, the sum of squared errors. It ends up being a very important statistic when you're finding lines of best fit. Okay? So this is my line, and I've got a residual of negative 1.9. Hopefully your guess will beat that. And then I've got a sum of squared errors about 4.81, and also hopefully you'll be able to do get something that's lower than that. And that's kind of the goal here, is to try and decide which of us ends up with the best fitting the line, the one that kind of minimizes these two values as much as possible. Okay, so, and then next time we'll kind of pick up in class with where we're going to go from here. So thanks for watching.